Hello guys, my name is Molly. I'm from IIR College, Mechanical Engineering. I want to tell about my presentation about magnetic properties and crystal structures of sputtered coffee films. This presentation explores the magnetic and structural, analyze the relationship between depositive parameters, crystal structure, and magnetic performance. The cobalt iron coffee yellow film have gained a significant attention in magnetic storage, spine tricks, and soft magnetic applications due to their excellent magnetic properties and structural stability. These films are often deposited using spectral techniques, which provides precise control over composition, thickness, and microstructure. Understanding the correlation between structural and magnetic properties is crucial for optimizing their performances. Deposition of coffee films. Sputtering is a widely used method to deposit coffee in films due to its ability to produce uniform high purity coatings. The process involves ejecting atoms from a coffee target using ionized gas, typically argon, and allowing these atoms to condense on a substrate. The sputtering parameters such as power, pressure, and substrate temperature significantly affect the film's properties. Sputtering depositions techniques and experimentally setup. This is the photo of this experiment, sputtering deposition and technique and experimental. Coffee target are bombarded with ions, releasing atoms that deposit onto the substrate. The deposition parameters such as gas, pressure, target, power, and substrate temperature significantly influence film properties. The crystal structure of coffee films. Coffee allows primarily crystallize in a body-centered cubic BCC structure when iron concentration is dominant, while face-centered cubic faces appear at higher goblet concentrations. The lattice constant and phase stability are influenced by depositing conditions and thermally treatments. X-ray diffractions. XRD is commonly used to analyze these structural variations. The peak position reveal the lattice spacing and crystal structure of the film. Peak intensities. Peak intensities provide information about the preferred crystal orientation and grain size. Microstructural characterization and gain morphology. SEM images reveal grain size and distribution which significance impact magnetic properties. Higher magnifications imaging allows for detailed analysis of invalidates individual gain and their boundaries. Microstructural analyzes the grain size and texture of sputtered coffee films play a crucial role in their magnetic behavior transformation. Electron microscopy team and atomic force microscope AFM reveal the Microstructural details showing variations in grain orientation and surface roughness based on deposition condition. Influence of composition of magnetic properties. Coffee ratio significantly affects the magnetic saturation, co-reactive, and entropy of the film. At approximately 30% Co and 70% Fe, they allow exhibits approximately soft magnetic properties with high saturation, magnetization, and low correlative, making it ideal for applications such as magnetic sensor and transfer scores. Effects of film thickness. The thickness of sputtered coffee films alters their magnetic and structural properties. Think films below 50 nm often exhibit higher co-reactive due to increased surface scattering and strain, whereas thicker films above 200 nm develop lower co-reactive and higher performability due to improved crystalline and reduced defects. Impact of deposition parameters on films, gas pressure, and target power. Gas pressure and target power controls the energy of the ions bombarding the target, influencing film thickness and morphology. Target power impacts the deposition rates. These energy of deposited atoms effective grain size microstructure. Substrate influence on crystal growth. The choice of substrate such as silicon, glass, or sapphire affects the crystallographic orientation and magnetic domain structure of coffee films. Highly crystalline substrates promote expressive growth, leading to enhanced soft magnetic properties. And the role of annealing. Post-deposition annealing improves the structural and magnetic properties of cofilms by reducing internal stress, enhancing crystallinity, and optimizing gain orientation. Annealing at a moderate temperature like 300 to 500 degrees Celsius result in a reduction in correlative and an increase in saturation magnetization, surface roughness, and magnetic properties. The surface roughness influence the domain, wall moment, and co-reactive of cofilm. Higher roughness increases pining sites for domain walls, leading to higher co-reactive, smoother surface achieved through controlled sputtering. Parameters contribute to lower co-reactive and better soft magnetic performance. Co-reactive and anisotropy. The co-reactive of sputter coffee film depends on factors such as gain, size, crystal orientation, and residual stress. Film with strong entropy exhibit controlled magnetic switching behavior, which is essential for applications like magnetic recording media and spintronic devices. Magnet magnetization reveals mechanisms. Magnetization reveals in coffee films occurs through domain wall motion and coherent rotation. Thin films exhibit localized nucleation and domain wall motion, while thicker film favor rotation due to the reduction of pinning effect, stress and strain effect. Internal stress is protected films arise from lattice mistake and thermal expansion differences between the films and substrates. Tensile stress trends reduce corrective while compressive stress interacts increase it. Controlling stress during deposition is critical for achieving desirable magnetic properties. And finally, the conclusion of this PPT conclusion for future research direction this Spurger co-film exhibition tenable magnetic and structural properties, making them invaluable in magnetic storage software magnetic applications by optimizing deposition parameters, composition, and post-processing techniques. Their performing can be further enhanced. This is my PPT and my presentation. Thank you for watching. Thank you.